The Moon, our constant celestial companion, has been the subject of wonder and speculation for centuries. What if I told you that hidden secrets and unexplained phenomena on its surface have baffled even the brightest minds? From startling lights that flicker across its terrain to peculiar geological formations that defy our understanding, the Moon holds mysteries that challenge everything we thought we knew. In this video, we will uncover 25 unexplained lunar anomalies that continue to puzzle scientists and thrill space enthusiasts across the globe. Each anomaly offers a glimpse into the strange and the mystical, promising to transform your perception of our nearest neighbor in space. So, buckle up for a journey through the Moon's most perplexing secrets, where every revelation brings us closer to understanding the enigma that has captured our imagination since the dawn of humanity. Stay with us as we dive deep into these captivating mysteries that lie just beyond our reach. The Moon's unusual orbit is our first stop on this lunar mystery tour. Unlike many other celestial bodies that orbit in a more circular fashion, the Moon's path is distinctly elliptical. This peculiar shape means that at times the Moon is significantly closer to us, a point known as perigee, while at others it drifts further away, reaching what's called apogee. This constant change in distance not only affects how we perceive the Moon's size from Earth, but also raises intriguing questions about how this orbit came to be. Most moons in our solar system have orbits that reflect a more predictable path because of the gravitational forces exerted by their parent planets. However, our moon's elliptical trajectory suggests a history that is anything but ordinary. Some scientists speculate whether this orbit is a relic of its formation, hinting at a chaotic past when the Moon might have been captured by Earth rather than forming alongside it. Others suggest it could be a result of gravitational interactions with other celestial bodies in the distant past. The mystery of the Moon's unusual orbit continues to be a topic of debate, prompting further exploration into its origins and the forces that shaped its current path. As we ponder these possibilities, the Moon's orbit serves as a reminder of the complexity and wonder that our celestial neighbor inspires. The hollow moon theory is our next fascinating stop on this cosmic journey. This theory, shrouded in controversy, posits that the Moon is not a solid body as we have long assumed, but rather a hollow one. This intriguing idea first gained traction in the mid-20th century, largely due to the unusual findings from the Apollo missions. Astronauts recorded seismic activity on the Moon that led some to speculate it might be composed of hollow space rather than solid rock. What might these seismic readings mean, and why do they fuel such a bold hypothesis? Proponents of the hollow moon theory argue that the Moon's density, which is significantly lower than Earth's, supports the idea of a hollow core. They suggest that natural celestial bodies of similar size should be denser if composed of solid rock. This theory, while captivating, faces significant challenges from the scientific community. Critics point to geological surveys and Apollo mission data, which reveal a layered structure akin to Earth's, suggesting a solid interior. Nonetheless, the hollow moon theory persists in popular culture, hinting at a celestial architecture far different from our understanding. As we navigate through these scientific debates, this theory offers a reminder of how our quest for knowledge often leads to more questions than answers. Whether the Moon is the solid satellite we've always believed it to be or a hollow enigma, its mysteries continue to beckon, urging us to unravel the secrets of our nearest neighbor in the cosmos. The formation of Lunar Maria is a captivating mystery that draws us deeper into the enigmatic nature of the Moon. These vast, dark plains are easily visible to the naked eye, creating familiar patterns that have sparked human curiosity for generations. But what exactly are these Maria, and why do they continue to puzzle scientists? Typically formed by ancient volcanic activity, Lunar Maria are thought to be large basaltic plains. However, their sheer size and the processes that led to such extensive volcanic activity remain topics of intense debate. the composition of Maria is notably rich in iron and titanium compared to the lighter-colored highlands, suggesting a complex geological history that differs from the rest of the lunar surface. This difference prompts questions about the Moon's internal structure and whether its volcanic past was influenced by planetary processes unlike those seen on Earth. Another layer of intrigue is added by the fact that most of these Maria are located on the near side of the Moon, which raises questions about what unique conditions could have contributed to such a distribution. Some researchers propose that the thickness of the Moon's crust and varying levels of solar and cosmic radiation might have played a role, yet no definitive explanation has been established. As scientists probe deeper, the Lunar Maria challenge our understanding of planetary formation and volcanic activity, standing as testament to the Moon's multifaceted history, a narrative still waiting to be fully unraveled. One of the most intriguing geological puzzles of the Lunar Maria lies in understanding the discrepancies in volcanic activity compared to Earth. Scientific studies have delved into the unique properties of the Moon's surface, examining why these vast plains, which cover roughly 16% of the lunar surface, exhibit such distinct geological features. Researchers have utilized data from lunar missions, lab analyses of lunar rock samples, and advanced computer simulations to reconstruct the Moon's volcanic history. These studies highlight that the lava flows which formed the Maria were unusually thin yet expansive, allowing them to cover large areas rather than accumulating into massive peaks or cones like terrestrial volcanoes. This characteristic suggests a lower viscosity of the lunar lava, potentially due to different chemical compositions, which has sparked debates about the Moon's internal processes. Additionally, the inconsistency in the distribution of Maria between the near and far sides of the Moon adds another layer to this puzzle. Scientists are investigating whether this phenomenon is due to gravitational influences, differences in crustal thickness, or thermal variations during the Moon's formation. Despite these efforts, the complete picture remains elusive. Each discovery about the Lunar Maria's geological puzzles not only enhances our understanding of the Moon, but also provides insights that could reshape our perception of planetary evolution in the universe. As research continues, these enigmatic formations remind us that uncovering one mystery often leads to the unraveling of yet another, driving our quest to decode the Moon's ancient secrets. Moonquakes present a fascinating window into the interior workings of our lunar neighbor. Unlike earthquakes, which are driven by tectonic activity, moonquakes are believed to originate from different sources, including the gravitational pull from Earth, the expansion and contraction caused by temperature fluctuations, and even the impact of meteoroids. These quakes have been recorded in various forms, ranging from deep moonquakes occurring hundreds of miles beneath the surface to shallow quakes that cause surprisingly potent vibrations. The Apollo missions equipped the Moon with seismometers, which have provided invaluable data, revealing that moonquakes, though less frequent than their terrestrial counterparts, can last for extended periods, sometimes up to an hour. The intensity and duration of these quakes raise intriguing questions about the Moon's internal composition. The observed patterns suggest that the Moon has a more rigid and less forgiving structure compared to Earth's, potentially consisting of a partially molten core and a rigid outer layer. This rigidity might explain why vibrations from moonquakes resonate longer through the Moon's body. Additionally, the Moon's lack of a significant atmosphere means that its surface is subjected to a wider range of temperature variations, which may contribute further to these phenomena. Altogether, moonquakes not only provide insights into the Moon's current geological state, but also hint at its dynamic history and the forces that continue to shape it from within and beyond. As we unravel the mysteries behind these quakes, they add yet another layer of complexity to our understanding of the Moon, encouraging ongoing study and exploration. The Moon's atmosphere, or more accurately its exosphere, is an astonishing discovery that defies our expectations. For centuries, the Moon was thought to be completely devoid of any atmosphere due to its small size and low gravitational pull. However, modern scientific instruments have detected the presence of a thin layer of gases clinging to the lunar surface. This exosphere is composed of rare gases such as helium, neon, and hydrogen, which are constantly replenished by the solar wind and outgassing from the Moon's surface. The presence of this delicate atmosphere raises intriguing questions about its formation and stability. How do these gases manage to persist in an environment with no weather systems to distribute them? And what implications does this have on potential future lunar exploration? One of the most exciting aspects of this discovery is what it suggests about the Moon's history and its interactions with the solar system. The exosphere might act as a witness to ancient geological processes or cosmic events that have left their mark on the Moon's surface. Additionally, understanding the dynamics of the lunar atmosphere could offer clues about the potential habitability of other celestial bodies with similar conditions. As scientists continue to study this ethereal layer, they are uncovering new insights about the Moon's environmental conditions, both past and present. This mystery of the Moon's atmosphere invites us to question what else might be hidden just out of sight, waiting to be revealed with further exploration and technological advancements. Unexplained lunar lights have long tantalized astronomers and observers alike, appearing as fleeting glimmers on the Moon's surface. These transient lunar phenomena have been documented for centuries, with reports describing flashes, glowing orbs, and even patterns of light that seem to dance across the barren landscape. While some early descriptions came from amateur astronomers peering through telescopes, modern technology has allowed scientists to capture and analyze these mysterious lights with greater precision. The explanations for these phenomena are as varied as the descriptions themselves. Some propose that the lights are the result of meteor impacts, which create momentary bursts of light when they strike the lunar surface. Others suggest that these glimmers might arise from the Moon's seismic activities, where the release of gases could ignite brief, luminous events. There's also speculation that the lights could be reflections of sunlight off the surfaces of lunar rocks, especially when the angle of view aligns perfectly with the sun's position. Despite these theories, no single explanation has been universally accepted, and the lunar lights remain an active field of study. The allure of these mysterious glows lies not only in their visual spectacle, but also in the potential they hold for uncovering new aspects of lunar science. As technology advances and our methods of observation improve, we may come closer to understanding the true nature of these unexplained lunar lights, adding yet another chapter to the Moon's enigmatic story. Historical sightings of these lunar lights have been recorded for centuries, dating back to the time when astronomers first turned their telescopes skyward. One of the earliest known accounts comes from a French astronomer named Gassendi, who in the 17th century noted mysterious lights on the Moon's surface. Over the years, many others have reported seeing similar phenomena. For instance, in the late 1900s, observers claimed to witness unusual glowing spots near the lunar craters. Such reports have fueled fascination and skepticism alike, prompting scientists and enthusiasts to seek potential explanations. Fast forward to the modern era, and the advent of advanced telescopic technology has allowed researchers to document these lights more accurately. In some cases, digital imaging and spectral analysis have captured instances of light that seem to appear and disappear without an obvious cause. These observations have reignited interest in understanding the transient lunar phenomena and have led to a series of studies attempting to pinpoint their origins. Despite the advances in technology and data collection, the question of what causes these lights persists, sparking debates and discussions within the scientific community. Some researchers argue that they might be the optical illusions created by atmospheric effects, while others believe they could be related to a previously unknown lunar activity. Yet, as with many mysteries, there is no consensus. The historical and modern sightings of lunar lights serve as a reminder that our celestial neighbor still holds secrets waiting to be uncovered. As ongoing research continues to explore these enigmatic glimmers, they challenge our understanding and inspire a sense of wonder about the moon's continuing mysteries. The discovery of water molecules on the moon is a groundbreaking moment that has transformed our understanding of the lunar surface. Contrary to long-held beliefs that the moon was completely arid, recent findings from spacecraft like NASA's a lunar crater observation and sensing satellite have revealed traces of water molecules embedded in the lunar soil. But how did these molecules end up there, and what implications do they have for the moon's history and future exploration? The origin of lunar water is a subject of intense scientific debate. Some researchers propose that water molecules could be delivered via comet and meteor impacts, bringing ice that becomes trapped in the cold, shadowed craters. Alternatively, interactions between the solar wind and the lunar surface might also generate water by causing hydrogen ions to bond with oxygen in the soil. These processes suggest a more dynamic lunar surface than previously thought, one capable of sustaining occasional changes in its composition. Beyond the mystery of its origins, the distribution of water on the moon is equally perplexing. Water seems to be more abundant at the poles, where temperatures are frigid enough for ice to survive, yet its presence in sunlit areas raises questions about the mechanisms that allow it to persist. Understanding this distribution is crucial, as it holds the potential to support future human exploration and even the establishment of lunar outposts, offering a resource for life support and fuel production. As scientists continue to analyze data and conduct experiments, the presence of water on the moon not only challenges our perceptions but also opens new avenues for exploration and discovery. This glimpse into the moon's watery mystery propels us further on our quest to uncover the secrets of our nearest celestial neighbor. The unusual composition of moon rocks opens a window into the moon's mysterious history that continues to intrigue scientists. When astronauts first returned with moon rock samples from the Apollo missions, expectations were high. However, these samples, upon analysis, revealed unexpected surprises that prompted a reevaluation of our understanding of the moon's formation. Moon rocks exhibit peculiar chemical signatures, notably differing from Earth's rocks in their isotopic compositions. One striking discovery is that moon rocks lack certain elements typically found on Earth, such as water and other volatile compounds, suggesting that processes involved in the moon's formation were vastly different from our planet's. Additionally, the high concentration of titanium and other unique isotopes presents a puzzle that challenges existing theories about the origins of celestial bodies. These disparities offer evidence that the moon might have formed from a massive impact event, where debris from Earth and another celestial body coalesced, but the exact details are still highly debated. The presence of anorthosite, a type of rock, points to a history of a molten lunar surface that gradually solidified into a crust. These findings illuminate a dynamic past, potentially involving a molten ocean of magma on the early moon. As scientists continue to delve into these samples with advanced technology, the unusual composition of moon rocks not only enriches our understanding of the moon's past, but also shapes questions about planet formation in our solar system and beyond. The journey begun by those early Apollo missions continues, as each rock sample holds secrets yet to be fully interpreted, urging us to further explore the moon's enigmatic story. Examining the unexpected elements found in lunar samples offers a glimpse into the moon's unique and complex history. Among the most surprising findings are the presence of isotopes that differ significantly from those on Earth. Scientists have discovered that some isotopes, like oxygen, present in the moon's rocks are remarkably similar to Earth's, leading us to question the relationship between the two bodies. This similarity suggests a shared history, possibly stemming from the giant impact hypothesis, which posits that the Moon was formed from the debris of a colossal collision between Earth and a Mars-sized body. Yet, other isotopes present a more perplexing picture. For instance, variations in titanium and chromium isotopes in lunar materials are distinct from those typically found on Earth, hinting at processes that might have occurred in a different environment or involved different source materials. These unexpected discrepancies challenge our understanding of the Moon's origin and suggest that the formation and evolution of celestial bodies may involve more varied and complex mechanisms than previously thought. Such findings have far-reaching implications for our understanding of planetary science, as they not only inform us about the Moon's past but also about the processes that shape planets and moons across the solar system. As we continue to analyze these unexpected elements with advanced technology, we may uncover further insights that refine or redefine theories about how our own planet and its neighbor came to be. Each unexpected element and isotope deepens the mystery, drawing us ever closer to unraveling the cosmic tale of the Moon's formation and its ongoing story in our universe. The near and far sides of the Moon present a perplexing enigma that has fascinated researchers for decades. While the near side, which always faces Earth, is dotted with the dark basaltic plains known as Lunar Maria, the far side appears drastically different, mostly covered in rugged, cratered highlands. This striking contrast has led scientists to question what geological forces could have created such diversity on the same celestial body. One theory suggests the differences stem from the thickness of the lunar crust, with the far side having a denser crust that inhibited volcanic activity, thereby reducing the formation of Maria. Another hypothesis posits that the Earth's gravity played a significant role in shaping the Moon's surface, with tidal forces influencing the distribution of heat and impacting volcanic processes more effectively on the near side. Additionally, the far side's lack of Maria and its abundance of craters raise questions about the impact history of the Moon, possibly suggesting a heavy bombardment period that shaped its current terrain. The far side's mystery deepens when considering the distribution of elements such as potassium, thorium, and uranium, which concentrate more on the near side, hinting at a complex past of volcanic and tectonic activity. Unraveling the reasons behind these stark differences is critical not just for understanding the Moon itself, but for offering insights into planetary formation and evolution. As scientists continue to explore these disparities, the near and far sides of the Moon remind us of the countless mysteries that await us beyond our planet, urging us to probe deeper into the universe's enigmatic past. The Moon's age controversy is a captivating subject that has sparked countless debates among scientists. The question of how old the Moon truly is remains unanswered due to the conflicting results obtained from various dating methods. Some methods, such as radiometric dating of moon rocks brought back by the Apollo missions, suggest that the Moon formed around 4.5 billion years ago, shortly after the solar system began to take shape. However, other analyses, particularly those focusing on lunar craters and the density of impact basins, indicate a younger age, raising questions about the timeline of its formation. The giant impact hypothesis, one prevailing theory regarding the Moon's origins, proposes that it formed from debris left after a colossal collision between a Mars-sized body and the early Earth. Yet, this scenario requires precise dating to match the geological evidence found both on the Moon and Earth. As scientists use advanced technology to reevaluate earlier data and apply new techniques such as isotopic analysis, each method brings its challenges and varying results, highlighting discrepancies that complicate the picture of the Moon's history. These challenges push the boundaries of our scientific capabilities, encouraging exploration and discourse on the Moon's true age. The Moon's age controversy serves as a reminder of the complexities and intricacies inherent in unraveling the history of celestial bodies. It invites us to continue probing our lunar companion, seeking answers that not only clarify the past but also enrich our understanding of planetary science. As the debate continues, the quest to accurately pinpoint the Moon's age remains a compelling chapter in the ever-evolving story of our solar system. The enigma of the Moon's weak magnetic field presents a puzzling anomaly that continues to intrigue scientists. Unlike Earth, which boasts a robust magnetic field generated by the movement within its molten iron core, the Moon's magnetic field is strikingly weak and inconsistent. This peculiarity raises numerous questions about the Moon's geological history and internal structure. How could a celestial body as significant as the Moon lack the powerful magnetic shield that Earth possesses? Investigations into lunar samples have revealed that some moon rocks are magnetized, implying that the Moon once harbored a more potent magnetic field. This finding suggests that the Moon's core may have undergone changes, leading to the loss or diminishment of its magnetic field over time. The reasons behind this transformation are still the subject of intense research and speculation. One theory proposes that the Moon's core cooled faster than Earth's, ceasing the convective motions necessary to sustain a magnetic field. Another hypothesis explores the possibility that significant asteroid impacts could have altered the Moon's magnetic characteristics, either by disrupting its core dynamics or through the formation of localized magnetic anomalies on its surface. The weak lunar magnetic field also has implications for understanding the Moon's evolution and its relationship with Earth. Without a magnetic shield, the Moon has been exposed to the solar wind and cosmic radiation, which could have influenced its surface and atmosphere over billions of years. This exposure may place a role in the Moon's surface weathering and even the mysterious exosphere we've previously discussed. As scientists delve deeper into these mysteries, the Moon's magnetic field remains a key piece in the puzzle of its complex history, offering insights that could enhance our understanding of planetary magnetism and its role in shaping the celestial bodies within our solar system. Unusual crater formation on the Moon presents one of the most perplexing mysteries in lunar science. At first glance, the craters dotting the Moon's surface seem typical of the impacts from asteroids and comets that have bombarded celestial bodies throughout our solar system's history. However, a closer examination reveals anomalies in their distribution and structure that defy easy explanation. Notably, certain craters exhibit disproportionately large central peaks or unusual shapes that do not align with standard impact models. These peaks are often found in craters where the depth and diameter ratios are inconsistent with those expected from conventional impact dynamics. Such formations raise questions about the impact energy and the geological processes at play during their creation. Additionally, the spatial distribution of craters, with some areas significantly more cratered than others, suggests that the Moon may have experienced periods of intense bombardment or that its surface responded differently to impacts over time. Some scientists propose that variations in the Moon's crustal thickness or composition might contribute to these anomalies, allowing certain regions to absorb impacts differently. Another intriguing possibility involves ancient volcanic activity influencing the Moon's surface, modifying or obscuring impact features in ways that are still not fully understood. The presence of multi-ringed or elongated craters adds to the complexity, hinting at a history of seismic activity or secondary impacts that reshaped initial formations. Each peculiar crater serves as a silent record of the cosmic events that have shaped the Moon, inviting ongoing investigation and interpretation. As researchers continue to analyze lunar data with advanced technologies, the enigma of these unusual crater formations promises to illuminate deeper secrets of the Moon's past, presenting opportunities to further understand the forces that have sculpted it into the celestial body we observe today. The scattered boulders on the Moon's surface present a tantalizing mystery that has both intrigued and puzzled scientists for decades. These large, isolated rocks are scattered across various lunar landscapes, sometimes found in surprisingly unexpected locations far from any apparent source. Theories about their origins abound, each more intriguing than the last. One prominent theory suggests that these boulders originated from high-energy impacts. When asteroids or comets collide with the Moon, the resulting force can eject massive rock fragments far from the impact site, depositing them across the lunar terrain. This explanation accounts for some of the scattered boulders, particularly those found in proximity to known impact craters. However, not all boulders fit this pattern, leading to further speculation. Another hypothesis posits that the Moon's seismic activity, or moonquakes, might be responsible for dislodging rocks from elevated regions such as the rims of craters, sending them tumbling across the surface. This process would explain the presence of boulders in regions where impacts seem unlikely. Yet another possibility involves the long-term effects of temperature changes on the Moon, where extreme thermal expansion and contraction could fracture larger rocks over time, causing them to gradually break free and scatter. The investigation into these enigmatic boulders is ongoing, as each new discovery adds layers to our understanding of the Moon's geological processes. As lunar exploration continues and technology advances, these scattered stones may one day offer clues not only about the Moon's past but about the broader history of our solar system, revealing insights into the dynamic forces that continue to shape celestial bodies. The Moon's gravity anomalies present a captivating puzzle for scientists, challenging our understanding of how gravitational forces behave on a celestial body. Unlike the Earth, where gravity is relatively uniform, the Moon exhibits significant variations in its gravitational field. These anomalies were first detected during the Apollo missions when spacecraft experienced unexpected deviations in their trajectories as they orbited the Moon. But what causes these fluctuations in gravity, and what can they tell us about the Moon's interior? One leading theory suggests that these anomalies, known as mascons or mass concentrations, are the result of immense impacts from ancient celestial collisions. These impacts may have caused dense materials from the Moon's mantle to shift and concentrate beneath the surface, creating localized regions of stronger gravitational pull. Another hypothesis links these variations to the Moon's unique geological features, such as its vast volcanic plains and deep impact basins, which could contribute to the uneven distribution of mass. Additionally, some scientists propose that the Moon's gravity field might reflect remnants of its early formation and evolution when its surface was bombarded by massive asteroids and comets. These gravity anomalies not only provide insights into the Moon's geological past, but also have practical implications for lunar exploration, affecting the navigation of spacecraft and influencing future missions aimed at lunar bases or resource extraction. As researchers continue to study these anomalies with advanced technology and simulations, they promise to unravel new aspects of the Moon's enigmatic nature, helping us piece together the complex history of our closest celestial neighbor. Through these investigations, we gain not only a better understanding of the Moon, but also valuable knowledge that could inform our exploration of other planetary bodies in the solar system. The unnatural lunar orbit presents a conundrum that captivates astronomers and physicists alike. Despite the Moon's significant size, it maintains an orbit that is surprisingly consistent in its characteristics, a peculiarity that sets it apart from many other natural satellites in our solar system. This consistency raises questions about whether the Moon's orbit could be the result of natural processes or if other factors are at play. One theory suggests that the Moon's orbit might have been influenced by a colossal collision in the distant past, leading to a stabilization that defies traditional models of orbital dynamics. Another possibility is that the unique gravitational relationship between the Earth and the Moon plays a role in maintaining this steady orbit, perhaps through intricate tidal interactions that have gradually adjusted their gravitational dance over eons. Calculations and simulations attempt to unravel the mechanisms that could account for the Moon's stable path, considering the complex interplay of forces and its significant mass. Some researchers even contemplate fringe theories that propose extraterrestrial manipulation, hinting at an artificially maintained orbit, a notion more at home in science fiction but nonetheless intriguing to consider. The Moon's unnatural orbit challenges our understanding of celestial mechanics, urging a re-examination of the fundamental principles of planetary motion. As scientists continue to ponder the reasons behind this anomaly, the Moon's orbit remains a beacon of mystery, drawing us to further explore the cosmic forces at work. This reminder of the complexities of our universe encourages us to keep searching for answers, knowing that the more we discover, the more profound our appreciation for the mysteries of space becomes. Lunar eclipses offer a fascinating spectacle, captivating observers as the Earth casts its shadow over the Moon. While this celestial event is mesmerizing in its own right, it also raises intriguing questions about the alignment and movement of celestial bodies. During a total lunar eclipse, the Earth, Sun, and Moon align perfectly, with the Earth positioned between the Sun and the Moon, casting a shadow on the lunar surface. This precise alignment is known as syzygy and presents a unique opportunity for scientists to study the interactions and orbits of these celestial entities. One question that arises is how the gravitational forces between these bodies influence the frequency and duration of lunar eclipses. The Moon's elliptical orbit means that not every full moon results in an eclipse, leading scientists to examine the factors that determine when these alignments occur. Additionally, during an eclipse, the Earth's atmosphere bends sunlight, creating a reddish tint on the Moon known as the blood moon. This phenomenon prompts questions about atmospheric conditions and their impact on the light that reaches the Moon. While lunar eclipses have been observed and recorded for millennia, their study continues to provide valuable insights into the dynamics of our solar system. Beyond the spectacle, eclipses invite exploration into the mechanics of orbits, the subtleties of gravitational pulls, and the delicate balance that allows such phenomena to occur. As we continue to delve into these celestial mysteries, each eclipse not only dazzles the eye but also enriches our understanding of the intricate dance of celestial bodies within our cosmic neighborhood. During lunar eclipses, observational oddities often capture the attention of astronomers, offering unexpected phenomena that challenge our comprehension of these celestial events. One example is the irregular timing of shadow progression observed during some eclipses, where the shadow seems to move faster or slower than predicted models suggest. This inconsistency has sparked investigation into the subtle gravitational effects and atmospheric interactions that may influence the shadow's path, prompting researchers to refine calculations and explore previously overlooked variables. Another intriguing phenomenon is the appearance of flashes or glows on the lunar surface during an eclipse. While some attribute these to atmospheric refraction or reflections off nearby celestial objects, others argue that they might be brief instances of light from distant stars bending around the Earth's atmosphere, a process known as gravitational lensing. The color changes observed during a lunar eclipse also provide fodder for exploration. While the characteristic red hue is well understood, occasional reports of bluish or greenish tints introduce questions about the specific atmospheric conditions influencing light filtration. These observational oddities highlight the complexities of celestial dynamics and atmospheric science, urging investigators to continually adapt and refine their understanding. As technology and observational methods advance, scientists are better equipped to capture and analyze these fleeting irregularities, turning them into opportunities to deepen our insights into the intricate workings of our solar system. By studying these phenomena, we not only come closer to unraveling the mysteries of lunar eclipses, but also cultivate a broader understanding of the interactions that govern celestial events, inspiring ongoing curiosity and inquiry into the enigmatic dance of shadows and light in the cosmos. The mysterious impact basins on the Moon stand as some of the most puzzling features in lunar geology. These expansive craters, such as the South Pole Aitken Basin, are among the largest in the solar system, stretching across hundreds of miles and plunging to remarkable depth. Their sheer size suggests that they were formed by massive impacts from celestial objects, likely asteroids or comets that collided with the young Moon. Yet the precise details of when and how these basins were formed remain shrouded in mystery. The age of these impact basins is a topic of intense scrutiny. Some scientists propose that they were created during the late heavy bombardment period, a time of frequent and intense collisions in the early solar system. Others suggest a more complex timeline where some basins may have formed later due to ongoing impacts. Determining the exact ages of these structures is challenging, not only due to the lack of direct dating techniques, but also because subsequent geological processes may have altered their surfaces. The basins also provide clues about the Moon's internal structure. The impact events that created them likely penetrated deep into the Moon's crust, exposing material that offers a glimpse of the underlying layers. Analyzing these materials helps scientists understand the composition and evolution of the Moon's interior. Additionally, the distribution and orientation of the basins raise questions about the gravitational forces that might have influenced their formation. As researchers continue to study these enigmatic features using remote sensing, computer simulations, and lunar sample analysis, they aim to unravel the complex history written in the Moon's scarred surface, shedding light on both its past and the dynamic processes that continue to shape celestial bodies across the universe. The Moon's mysterious dark spots have long intrigued both astronomers and casual observers alike, presenting a captivating enigma on our celestial companion's surface. Commonly known as Lunar Maria, these dark areas are a stark contrast to the lighter highlands, creating the familiar patterns we see when gazing up at the night sky. But what exactly are these enigmatic dark spots, and what secrets do they hold? Lunar Maria were first thought to be bodies of water by early astronomers, given their smooth and dark appearance. However, these vast plains are actually composed of basalt, a type of volcanic rock, formed by ancient volcanic eruptions that flooded the Moon's surface billions of years ago. Despite this understanding, many mysteries surrounding these dark spots remain unsolved. Their distribution raises intriguing questions as they predominantly exist on the Moon's near side, leaving the far side mostly free of such formations. This peculiar placement suggests a unique sequence of geothermal and impact events that influenced the Moon's geological history. Additionally, the exact chemical composition of these Maria adds layers to their mystery. Analysis reveals higher concentrations of iron and titanium compared to the surrounding highlands, indicating volcanic activity far different from that seen anywhere on Earth. The origin and age of these features also spark scientific curiosity. Some researchers propose that the Moon's proximity to Earth may have played a role, with tidal heating influencing volcanic activity. Meanwhile, dating these regions remains a challenge, with estimates suggesting they are over 3 billion years old. As scientists continue to explore the Moon with new technologies, these dark spots remain a focal point in unraveling the Moon's complex past. Each discovery about these mysterious spots not only informs us about the Moon's unique history, but also enhances our understanding of planetary processes that may occur throughout our solar system. The allure of these lunar features, with their dark appearance and mysterious origins, continues to inspire fascination and encourage further exploration, standing as silent witnesses to the dynamic forces that have shaped the Moon over eons. Strange artifacts in lunar photographs have long been a source of curiosity and debate among scientists and space enthusiasts alike. These intriguing anomalies, captured over decades of lunar exploration, include unusual shapes, shadows, and formations that sometimes appear in images taken by spacecraft and lunar missions. Some interpretations of these photographic oddities suggest they might be natural geological features altered by lighting and perspective. However, their peculiar appearances have led to a wide range of speculations, from suggestions of artificial structures to unknown lunar phenomena. The debate over these images is fueled by the difficulty in determining their true nature from a distance. While advanced imaging technology and detailed analysis have provided clearer views of the Moon's surface, the artifacts still provoke questions about what lies beyond our current understanding. Critics argue that the anomalies are purely the result of visual distortions or processing errors, common in the challenging environment of space photography. Supporters of other theories point to the consistency of some artifacts appearing in multiple images taken from different angles, challenging the notion of simple photographic glitches. This ongoing discussion highlights the challenge of interpreting visual data from another celestial body, a task that requires careful consideration and a willingness to explore both conventional and unconventional explanations. As technology advances and future missions provide new opportunities to capture lunar imagery, these strange artifacts remind us of the mysteries that continue to linger on the Moon. They encourage us to look closer, question what we see, and remain open to the possibilities that our universe might hold. Each photograph containing these anomalies offers not just a glimpse into the Moon's surface, but also an invitation to delve deeper into the unknown, urging humanity to reach further into space in pursuit of answers that remain elusive yet tantalizing. The missing basalt on the Moon presents a fascinating geological puzzle that continues to intrigue scientists. Basalt, a common volcanic rock found on Earth, is typically expected to be present in significant quantities on celestial bodies with volcanic histories such as the Moon. However, surprisingly, there appears to be less basalt on the lunar surface than scientists originally anticipated. This discrepancy raises intriguing questions about the Moon's volcanic past and the processes that shaped its surface. One of the primary theories suggests that the Moon's volcanic activity may have been more localized and less widespread than initially thought, leading to limited basalt formation. Additionally, the unique conditions of the Moon, such as its lower gravity and lack of atmosphere, might have influenced the way volcanic eruptions occurred, resulting in different lava flows and rock formations compared to Earth. Another possibility is that a portion of the Moon's basalt may have been buried beneath younger geological formations, hidden from view and challenging to detect with current methods. This raises questions about the chronological sequence of volcanic events on the Moon and whether there are layers of undiscovered basalt beneath the surface. Scientists use remote sensing, lunar samples, and computer models to examine the Moon's composition in an effort to resolve these mysteries. Each new discovery about the presence and distribution of basalt on the Moon not only enhances our understanding of its volcanic history, but also offers insights into the broader mechanisms of planetary formation and evolution. As research progresses, the missing basalt serves as a reminder of the complexities involved in piecing together the Moon's past, urging us to delve deeper into its geological mysteries and the forces that continue to shape it as one of our solar system's most remarkable celestial bodies. Unexplained thermal activity on the Moon adds yet another layer to its enigmatic nature, presenting puzzling phenomena that challenge our current scientific understanding. Recent lunar missions equipped with advanced instruments have detected hotspots and temperature anomalies on the Moon's surface, sparking curiosity about their origins. These thermal activities are intriguing because the Moon lacks an atmosphere to trap heat, leading scientists to question what could be causing these unexpected warm areas. One theory suggests that the residual heat from underground volcanic activity could be responsible. Although the Moon's volcanic activities are believed to have ceased billions of years ago, some researchers speculate that pockets of geothermal heat may still exist beneath the surface, causing temperature fluctuations detectable by modern instruments. Another possibility is that the thermal anomalies result from the Moon's interaction with external forces, such as solar wind or micrometeorite impact. These impacts could generate localized heating by compressing and releasing energy upon impact, creating transient hotspots. Additionally, the Moon's interaction with Earth's gravitational pull might induce minor movements or moonquakes that produce frictional heat in certain regions. These ideas, while compelling, remain speculative, and the precise mechanisms behind the observed thermal activities are still being investigated. As scientists continue to monitor these areas using satellites and lunar landers, they hope to gather more data to better understand the processes at work. Unraveling the mystery of these thermal activities not only enhances our knowledge of the Moon's current state, but could also provide insights into its geological history and the dynamics of celestial bodies with similar conditions across the solar system. Each discovery about the Moon's unexplained thermal activity is a step closer to solving one of the many riddles our lunar neighbor presents, urging further exploration and study into the fascinating complexities of its ever-unfolding story. As we come to the end of our incredible journey through the Moon's hidden mysteries, we've uncovered a wealth of enigmatic features that push the boundaries of what we know. From the Moon's unusual elliptical orbit and the captivating hollow moon theory to the formation of Lunar Maria and the puzzling presence of moonquakes, each anomaly offers a unique glimpse into the Moon's complex and dynamic history. We've also explored the thin lunar atmosphere, the transient lunar lights, and the groundbreaking discovery of water molecules, all of which challenge our preconceived notions about our lunar neighbor. Not to mention the peculiarities of moon rocks, the stark differences between the near and far sides, and the ongoing age controversy that fuels debates among scientists. As we delve deeper, the Moon's weak magnetic field and the riddles of unusual crater formations, scattered boulders, and gravity anomalies came to light, expanding our understanding of celestial bodies. The mysteries of the Moon's orbit and eclipses have highlighted the intricate dance of gravitational forces, while the impact basins and mysterious dark spots have kept us guessing about the Moon's geological past. Through strange artifacts in photos, the puzzle of missing basalt, and unexplained thermal activities, the Moon continues to beckon us with secrets yet to be uncovered. In unraveling these anomalies, we gain not only a better understanding of the Moon, but also insights into the processes that shape planets and moons throughout the cosmos. As each mystery unfolds, new questions emerge, drawing us further into the captivating world of space exploration. We invite you to ponder these lunar mysteries and share your thoughts or theories in the comments. And if you're eager for more space mysteries and cosmic wonders, be sure to subscribe, like this video, and hit the notification bell so you never miss an update. Thank you for joining us on this celestial journey, and until next time, keep looking up at the night sky, for there's always more to discover.